So I want to teach you this long division of polynomials because that's one of these top, for sure, top 10 hardest things on the ACT test, for example. And it's in this class, and it's on your next test. Okay, so you need to learn how to do this. But some of you are kind of toast on this because you don't even know how to long divide with two normal numbers. I'm not saying all of you, I'm saying some of you. So if I give you two normal numbers for long division and you can't do that, then we got to fix that. The cool thing is you're way smarter than you were when you first learned long division. So if you're like, oh, I never got that, well, now you're about 5 times smarter than you were back then. So you can learn it right now. If I had 8 going into 75, would you agree 8 goes into 75 a bunch of times? But there's some leftover. What's that leftover called? Remainder. So 8 goes into 75, and you might be like, why are you teaching us this? Because it's the same exact process, except we do it with variables in it. See, this has got variables down here. So I need to make sure you get how to do the process with regular numbers. So you ask yourself, does 8 go into 75? Yeah. And then you say, how many times can I put it in? I got to put something up here that's going to make sense. Well, can it go in there 10 times? 10 times 8 would be 80. It won't go in 10 times. How about 9? Yeah. Yep, you could do 9. So then you put a 9 right there. Everybody, please do this with me. Because you got to practice it once with normal numbers, because in a minute it's going to have variables and it'll be harder, but similar. All right, now would you agree that you go this times this? You multiply them together to get the next thing we do. 9 times 8, 72, so I put that here. Then you put a line like this. You're going to do all of those things when there's variables involved. You will. The next thing you do is really important, and with variables, I'm going to change how we frame it. Instead of saying you subtract the 72, I'm not going to say that. I'm going to say we change the sign of the 72. Because see, sometimes when you do this, you're going to be changing negatives to positives. All right, so you just change the sign of the red number there by putting the negative right there. And then you combine them. I'm not going to say subtract, because sometimes you're adding the numbers. You know, if this had been a negative number here and that had been a negative number there, we would have combined them together. It wouldn't have really been subtracting. Okay, so instead of saying subtract, I'm saying make this the opposite and then combine the two numbers. And combining negative 72 and 75 gives me 3. All right, and I know you all know that the remainder is 3, but the story's not over right there. Because some people think that that's the answer and you just say that it's 9, or maybe 9 remainder 3. But do you know what you're really supposed to do with the 3? Make what? All right, if we made it into a fraction, what fraction would it be? 9 3/8. Notice what we did there. We took this over that. Okay? Headphone out. Both sides if you have them in. All right. So 9 3/8 is your final answer. Or, this is important, you could say, and this is what we do with polynomials, that the answer is 8 times 9, which is 72, right? Plus 3. Do you agree that makes the 75 that we wanted? See what I'm doing? I'm adding the remainder. It's plus that. So it's this times this plus that. Or it could have been 8 times 9 3/8. Does that make sense? Okay, there's 2 ways you can do it. This way or this way. And for our purposes today, we're going to use this way where you add the remainder in at the end. Okay, so let's do one more with regular numbers to make sure you really got that. 7 goes into 20. And be conscious of each step you're doing. First you're going, does it go in? Yeah. So I'm putting a number on the top. Diego, what number are we putting on the top? 2. And then what are we doing, Sam, to the 2 numbers? Good. Madeline, after I multiply them, where do I put it? And then make it the opposite. I would like you to say make it the opposite instead of saying subtract, because sometimes there will be negative numbers that you make positive. All right, and then I combine these two, which, yeah, in this case happens to be subtracting. If the 20 had been negative, like it can be in our polynomial long division, then we would be combining the numbers. And I got 6 left. And then I hope you get that the answer to the 20 is that 7 times 2 are factors, but then you have to add on the remainder. Does that make sense to you? Okay. How many of you are confident you get long division with whole numbers? Okay, good. Now, let's extend it to what if you got something like this? Okay, so what they did here is they said that's the bigger number, and this goes into it. And what we're trying to figure out, is it a factor, or is there a remainder at the end? I never even did one where there was no remainder. Let me do it quick. Let's say 7 goes into 21. You go 7 goes into 21 3 times, but you make sure that that's right by going 7 times 3 is 21. Make it the opposite, and then I have 0 remainder. And what that meant was that this and this are factors. So what we're trying to figure out here is this really a factor of that? That's really what's happening. We're trying to see if this is a factor of, times this, sorry, and that therefore they are factors of this. So is this and this a factor of that? Okay, so then how do you get these numbers that go on the top? Well, you pick one. And my advice to you is I would always pick something that has an x in it. Because this is polynomial long division, the whole point of it is that it's got variables versus just regular long division doesn't have variables, right? So you got to start with an x. So you'd put an x right here, and then you'd go, if I go x times x, that's going to be x squared, and that's not enough to cancel that. So I better use an x squared. And then x squared times x, that'll be an x to the third, but then it doesn't have a 2. So then you realize, oh, it's got to be 2x squared. So that the 2x squared can multiply by the x and make 2x to the third. You see how those need to match up? All right, so I'm going to give you another one. And this one is one that you will probably be able to do without too much difficulty. You ready? I'm going to ask you if this is a factor of this by doing polynomial long division. But don't be deluded into thinking, oh, I can do this some other way that's easier. The problems that we give you, you won't be able to do any other way except polynomial long division. Okay, so you got to learn this process. All right, so the first thing I said is put an x up here. And then you go, if I multiply this times this, is that going to be enough to get it to match that first term? Yeah, it is. Because x times x makes x squared. Now, do I just go do the process where I draw the line and make it the opposite? No, you have to do a little other step. It has to be multiplied by both of them. X times the negative 9 makes negative 9x. See how I distributed that to both parts? Okay, now, remember me always saying you don't subtract? It's because of moments like this. If I now go make it the opposite, see how that is not going to be subtracting anymore? That's a positive 9x. It used to be negative. And this became a negative x squared. And then I always say combine these two, because that looks like subtracting. And yes, they do cancel each other out. But that doesn't look like subtracting to me, so I don't call it subtracting. I say combine them. All right, I'm combining the 9x and the negative 8x, and it makes x. And then do you remember this process on a long division problem? You just got to bring down the next number. And, oh my gosh, can I just be done because this matches this? No, you can't. You got to do one more thing. What do we put up here? Plus 1. And then the 1 times the x will make x. One times the x makes x, and 1 times the negative 9 makes negative 9. Then I draw a line, and then, please stick with the process, opposite, opposite, and then you combine them, and x and negative x cancel, and negative 9 and 9 cancel, and yay, I got a 0 remainder. And the polynomial remainder theorem, would you agree these are polynomials? Would you agree this is a remainder? Basically says that if you get a 0 at the end, if you have no remainder, then these were factors of this. Okay? And the more powerful thing is that since those are factors, then 9 is a 0 of the original. 9 is one of the zeros of this, which is like zeros, roots, x-intercepts, solutions, you know? And negative 1 is also a 0. I think you know that about factors, but keep that straight. This is the 0, and this is the factor that goes with this 0. One of them's a 0, one of them's a factor. Okay. Here's your overview, and now let's see if you remember anything about polynomials and sketching them and making it go through the right zeros and the bouncing and the cutting through, and the right end is down and the left end is what? Figure out if it's up or down. And my first tip, always find your first term and your last term, and you don't care about anything in between. Your first term would be negative 2x to the something. You figure out what. And then your last term, I don't know, but you need to figure out, is the y-intercept of this thing positive or negative, and what is it? To get your y-intercept, you set x equal to 0 is, to me, the easiest way. If you want the y-intercept, set this is 0, that's 0, that's 0, and then you see what you get for your y-intercept. Okay, I'm going to pause for a second while you guys give that a shot. Okay, let's go with Mr. K. Can you tell me what the y-intercept was? -8. Anybody verify -8? A lot of people are saying yes. Okay, good. So if I was going to sketch this thing, that's the first thing I do is put the -8 on there. It's really easy to forget the y-intercept. You won't forget these because they're pretty obvious. You need them. So this one's 1. This one's 2. This one's -1. And by the way, if there would have been an x out in front, then there would have been another 0 at 0 if there had been an x out front. A lot of people forget that one too. Like if it's like this, people go, oh, the intercepts are 3 and -1. Because they see these two, but then they just don't see that for some reason. The intercepts would have been 0 and 3 and -1. Okay, so don't forget if there's an x out front. All right, so now this is negative in front, so that means it's going down at the end, which is like that. All right, and then it's bouncing off of the 2, boing, and then it's cutting through at the other 2 spots. Cut through, and I know I did something wrong now. Well, this was 2x to the 3, 4, 5, 6, 7. I know I did a couple things wrong because my y-intercept isn't in the right spot. And I got them both going down, and that's like for an even degree, and this is odd. So what the heck went wrong? Yes?
You have to bounce at the 0 and 1.
Oh, there's another bounce. Okay, and that's what you need to be able to think through is like, why isn't this working? And it's often the y-intercept is messed up or that you forgot to bounce somewhere. All right, so I have to bounce also at this spot. Bounce, bounce, and then I go down through this, and then I can go up through that. And now I've got up and down, and that makes it right with the 7, because that's an odd number. And then my y-intercept is right, and my 3 zeros are good, and I'm bouncing in the right spots, and yay. I think it's right. Okay, yes?
X plus 1 in the third part, would it snake that?
Yes, but remember that there is no difference math-wise between passing through it and snaking through it. So yes, but these are really tricky to draw, and I don't want you to be obsessed with it because, again, talking to the calculus teachers, they say it really doesn't matter. It just as long as you know it passes through it as opposed to bouncing it. Okay, So, let's get back to the polynomial long division. See this one? You should be able to figure out how to start. Sean, do you remember I always said to go on the top and put something? Remember what? Something goes right here.
X squared.
I said to start with an x and see if it works. And you're right that x times x is not going to be enough to match this. So you're right. X squared goes up there. What you're doing is you're trying to make it match. Now that x squared times x matches, you found the right thing. And then you distribute it to both parts. Negative 2x squared. All right. Miss Woke, can you tell me what to do next?
Add a negative to,
Yep. I'm changing both of their signs. And now this cancels this, and this doesn't cancel that. They actually add together. Again, one of the reasons I don't say and subtract them, because I'm not actually subtracting. I'm combining them, and I get 6x squared in this case. And then you got to bring a term down, negative 5x. McLean, what's next? Hint, something up here.
Yeah, another X.
Another x. Then let's think through, would that be enough? Is x times x going to match this up? So, 6x. And let's make sure it's clear that as positive 6x. Okay, so I'm going to say positive 6x, and then 6x times x is 6x squared. Sweet. If you match the first term, you're good. Vivian, after I have done that, what's my next step? Multiply by the other thing.
yeah.
So what's that?
Is it just the 6x?
6x times negative 2. Yep. And then do you remember the next step, Vivian?
It would be just flipping the side.
Yep. Opposite, opposite. Asher, take over from there.
Then you're left with 7x,
Yep.
and then you carry down the minus 14.
Bring down the minus 14. And then does that give you a hint of what goes up here?
Yes.
What?
If you factor out 7.
Yeah. So then I'm going to use a 7 up here. 7 times x, 7x. 7 times the negative 2, negative 14. And don't just skip on this last step. Opposite, opposite. Because sometimes you get fooled. And when you actually make the signs different, it doesn't all cancel. But in this case, it all cancels. And you have a 0. And that 0 is really important. Because by having a 0 there, you're saying it worked. And this are factors. Now step back for a second. Do you get we just factored something really complicated? We just factored this thing, and it was really complicated, and you just factored it. But, oh, it's so sad. A lot of people get this far, and then they go, so it's factored. And they write these two down, which you need to do, but then they don't even notice that that might be able to be factored. Just because you factored one thing out doesn't mean you couldn't factor it again. But in this case, can this be factored? No, because if I made it x plus 1 and x plus 7, that doesn't make 6x in the middle, so I can't actually factor it. But watch out for that. I almost guarantee you we're going to do that to you. You'll factor one thing out, and then you'll have something left that can be factored again. Okay, so look to factor it all the way. That's one of the best things about factoring is that you got to keep going and going until you're finally done and you got it all the way factored and you found all the zeros. In this case, I know one of the zeros is x equals 2. And one of the things that they use that on for the ACT is to see if you notice then that 2 is a 0, as in 2 will make the original equation equal 0. Do you get if I put a 2 here and here and here, it will make it equal 0. That's one of the facts you got to draw from this. Not just that you can factor it, but that means the 2 is a root or a 0 of the function. So that would make all of this equal 0 when you put it in there. All right. This is called synthetic division, and I'm making the call that this year, it's just a waste of time. Some people did this last year and liked it, and that's neat because it's a neat trick, but the thing is, it won't work on the hard problems. And we are going to do the hard problems. Last year, you didn't do the hard problems, and so it was fine to use this little synthetic division trick. But long division solves the easy ones and the hard ones, and so we're only going to use long division this year. Okay, so here is just a reminder of the same thing I just said, that there's a connection between the zeros and the factors. As in, if you factor something and it's x minus 7, you just said that 7 makes this thing equal 0. So then if I put in a 7 in this, I'm not saying 7, but if I put a 7 in that, it will make it equal 0. So this c right here equals 2. You can check and see if it's a 0 by sticking c in here. Wait, not the 8. Stick the c into the x and this x and this x, and if that c, when you stick it in, makes it equal 0, then do you get one of the factors was x minus 2? Get what I mean? If 2 makes it equal 0, then that means that you have an x minus 2 factor. Okay. So, and then we're supposed to factor it if that's true. Well, so let's just stick a 2 in here. Would you agree that this makes it 3 times 2 to the third, which is 8, minus 6 times 2 squared is 4, plus 4 times 2 is 8, minus 8. Well, that kind of worked out nicely. 8 and the minus 8 cancel each other out. And 24 minus 24, oh my gosh, it does equal 0. Do you get I now know for sure that 2 is a 0, and therefore x minus 2 is a factor? Well, if x minus 2 is a factor, then I can go do long division with that, and it'll work. All right, so this x minus 2 here, it wants to go into this other thing. I'm going to try starting with an x. That's my best advice. Always just start with the x and see if it worked. That makes x squared. No, not going to work. X squared up there would make x to the third, and that really got close, so then I knew it was 3x squared, who was already there and had 3x squared on the top. Okay, awesome. So let's say it's 3x to the third now, and now I'm going to distribute it to the other part. Yes.
Thank you.
Negative 6x squared, and I draw the line and I do opposite. And this is one of those moments where it would have been really easy to forget that you change both signs. And oh my gosh, they both drop out. 0, 0. Can that happen? Yep. That just means you need to bring down 2 things. And what it also means, and it's not required, is that there was a 0x right here. That doesn't matter though, does it? Because the 0x is not really there, right? You think I'm going to make you write a 0x on the top? Of course not. And then, can you finish it off, Sam? What goes here? 4x is 4x, and then 4 times negative 2 is negative 8, and opposite, and I get 0. Yay! That meant it worked, and that's a plus, because it wasn't a minus. And there's my answer, x minus 2, and x squared plus 4. Now what are the roots? That one's 2, and I know before that I've told you that something like this can't factor, but it actually can. It just uses imaginaries. Yes? Okay, wait a minute. Where do you think you see the mistake? Which is very possible.
It's at the top. It's 3x.
Oh, thank you. Thank you. I just copied it wrong. There's a 3 there. You're right. Okay. So if I'm solving this, I got x equals 2. If you're solving this, pretty quick you'll realize that you can't make it equal 0. Why? Because 3x squared equals negative 4, and then You divide both sides by 3 and you got x squared equaling a negative. How is that possible? It's not. But if you needed to, you could just say that there is 2 imaginary roots right there. Why do we need to care about that? Because we're supposed to find 3. You know, it's to the third. There's supposed to be 3 answers. One of them is this, and 2 of them would be this. You could put it into the quadratic formula right now, or you could go square root. Wait, it is square root of a negative, isn't it, Mr. Server? Yeah, I know, but we're going to get absolute value of x equals square root of a negative is fine as long as you take the I and put it on the outside, and then you have 4/3 here. And then since this square root of a variable is actually absolute value, and then that splits into 2 things, x equals I, and then I'm going to not try to simplify this yet because I think it'll freak too many people out. And x equals I square root of 4/3. But then that's really got a square root of 4 in it. What is the square root of 4? So then it's really I, and oops, I forgot a negative. This is supposed to be a negative on this one. Now, I don't mean the I mean when you split, you know, the other one has a negative right there. Oops, I caught it myself at least. Okay, now this one's the square root of 4 over the square root of 3. You can do that if you didn't know that. You can do that. And then the square root of 4 is really 2. Oh my gosh. Do you see why I wanted kids to learn all the basics of algebra? Because we had to do like 17 little things there. You had to know how to break up your square root of 4/3. So now my answer is I, which is that on the bottom or the top? Top. 2I over root 3. And that even has a square root in the denominator, which some schools don't allow. But on the calc test, they allow that to be left that way. But just so you know, some of the problems that we have will force you to multiply by root 3 over root 3, because then that makes this turn into root 9, which is 3. So then it would be 2I square root of 3 all over root 9, which is 3. My gosh, complicated stuff. And then this one, which would be negative 2I over the square root of 3 to start with, and then multiply by root 3, and root 3, and then I have negative 2I root 3 all over 3. Whew! Hello! Those are the imaginary roots. Yeah, hardcore. Hey, you took honors. Somewhere in your head you said, I would like a challenge. So, this is that moment where maybe you were forced to take honors by evil tyrants. I don't know. All right, so let's go to another one. Everybody get to this page. Would you agree that the c equals 5 is implying that 5 is the root, and therefore the factor should be x minus 5? It'd be really easy to forget and put x plus 5. I'm not even going to test it because I don't think they would do that to me that make it not work. So then I'm going to go 3x to the third minus 2x squared minus 61x minus 20. Ugh. Not fun. But maybe it is fun. Just a different kind of fun. It's like a challenge. Can you figure it out? Where a lot of people can't. And some people get some fun in being able to do stuff that other people can't. All right. So I put 3x squared up there because if I times it by x, then it's 3x to the third. I know I'm on the right track because it's matching up. Then I go this times this. Negative 15x squared. Draw the line. Opposite, opposite. These two cancel. Positive 13x squared. Bring this down. Minus 6x. Then think, you're starting to get the hang of this? Whoa, whoa.
61.
Oh, it's a 61. I just copied it wrong. I get it. Thank you. I should have been more careful here. 61. Thank you. Right there. Okay. 61x. Okay. Now, I'm going to go up to the top again. I'm putting in a plus 13 because 13 times x makes 13x. And then that would be a moment where you go, oops, I needed an extra x there. 13x times x makes 13x squared. And then distribute to the other part, which is negative 5. 50, 65, and it's negative 65x. I think. Did I do 5 times 13 right? I think so. Yep. And then opposite, opposite. These two cancel. This becomes 4x. Bring down the negative 20. Ooh, it's a really a good sign if these factor, you know, like 4x minus 20 factors. Okay, then I'm going to go 4 here. 4 times the x, 4x. 4 times the negative 5, negative 20. Draw the line, opposite, opposite, 0. Sweet, it worked. And my answer, which you always have to do at the end, is sum up. What did you just do? You just factored it. Is there anything else I should do?
Yeah, I think you factored it.
Aha! Yes! Somebody remembered. Because that's what's going to happen on the test. You do all that work and then you're like, phew, I'm done. And then no, you're not done. 3x and x. And now I don't know it, but I don't want you to tell me. Because I want the challenge of like, what goes here and here. I always do the signs next. It's got to be plus and plus because there's all pluses. Then it's got to be, well, it could be a 4 and a 1. Or a 2 and a 2. Ooh, it's a 4 and a 1. Because this 4 here will go with that 3 to make a 12. And then that 1 will make 1x, makes 13x. Sweet, I've got it. But do you see how easy it would have been to forget the last factor? Okay. So always check yourself before you wreck yourself on the test. Because you could go all this way and I have to go, sorry. No credit. And if they had asked for the zeros, you should have said, there's 3 of them. Can you do these in your head pretty quick by now? X equals 5, x equals negative 1/3, and x equals negative 4. And those are the x-intercepts. And there's nothing squared, you know, like there are multiplicities are all 1, so there's no bounces. So if I even had to sketch this crazy looking thing, I could. I know all the x-intercepts. I could get the y-intercept real easy by setting x equals 0. So this, and this would all cancel, and the y-intercept's negative 20. You know what I mean? So I could sketch it super easy. Negative 20 y-intercept goes through 5, negative 4, and negative 1/3. It was positive in the front, so it's going up here, and they're all cut throughs. And then I got to make sure it was odd because they're going opposite directions, and it was odd. Sweet. Okay. Feeling smarter than when you walked in today? That's some complicated stuff. I know this is not the true test of something, but if you walk out on the street and you go to like a store and you grab a random person and you say, polynomial long division, go. Like, what percentage of people do you think could do that? I don't know. Half of 1%, maybe? So you need to ask 200 people before you finally run into some engineer who's like, I think I can remember that. Okay. Work time. Let me show you what to do. Question first.
So, kind of based off of that, what are some of the real-world applications of these kinds of problems?
Real-world applications. Okay, let's talk about the polynomial box problem again, just for a second. Do you get how this simple piece of cardboard, where this was x, 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 and x, ended up turning into a polynomial? And then once I had the polynomial, I could graph it and optimize it. Do you get that people are using data in businesses all the time now? And they can optimize and go, you know, if we set our price here, we can make the most profit. Do you get that Tesla could probably sell their cars for $20,000 more than they sell them for, but less people would buy them, right? So somebody smart is sitting in a back room optimizing and going, well, let's try setting the price do you agree that if they set the price 5,000 lower, they could sell even more of them? What if they made it 5,000 lower than that? Could they sell even more of them? Yeah. And so you got to figure out where's the maximum where you, because if they set the price too low, they don't make any money. So what they're trying to do is not maximize how many they sell. Otherwise, they would just set the price to 0 and everybody gets free cars. Yay, but they lose tons of money. So they're trying to optimize profit. And so that's the kind of thing where you'd graph something like this and you'd figure out what price to set. Yes? A little louder.
Amazon, because they have cheaper prices so they sell more.
So, but you can't just have your only strategy be to set the price cheap. Because otherwise, if you set your price cheap, but then everybody's getting burned by not having good service or the crappy quality or whatever. So you have to have the right mix. But Amazon didn't just go for low price. I think Amazon went for simple. Because you can click it and a couple of days from now it'll be at your door. You don't have to even go anywhere. So I don't think Amazon's got the lowest prices really. They just made it really simple. One of the things that I've heard that Elon Musk is talking about doing with Twitter is he wants to make it super simple to get around and buy things so that like literally you can have it set up where you like that thing, one touch button and it will arrive at your house a couple days later. Like one touch. Like not even like confirm everything. Just boop, I touch it and then it arrives at my house later.
Oh, so if you hit it accidentally, then you.
Well, if you had it accidentally, they might have some kind of a like email that comes to you that says, we're shipping that thing you just bought. And then you'd have to get back to them pretty quick to go, no, I didn't mean to. Right? But simplicity is still a thing. I think people can make even more on that progress in that area. All right, I need to get to the homework and tell you which one I would do if I were you. So I'm going to recommend that you do this one because it'll be gentle and easy, and this one because it won't be. But I would strongly recommend that you do 7, 11, and wait, sit down, 7, 11, and 23. And that's it. If you do those 3 for practice tonight, 7, 11, and 23, you'll be in good shape. That's all I got for the video for today.